Can you guys hear me? If you guys can hear me, can you just comment? Okay. So good evening, everyone, and welcome back. I hope you guys are having fun at Technica. I'd like to ask you guys how your overall hack experience has been going on, and what do you think about our previous speaker sessions? Um, hey, Aman. So, moving on, a little bit about myself. I am Khoshang Thakkar, and I'm a core committee member at ISTE VIT. ISTE is a national professional and non-profit making society whose goal is to assist and contribute in the production and development of professional engineers and technicians which are required by industries and other organizations. We at ISD VIT have lined up another exciting session for you guys where we'll be exploring the magic of serverless with AWS. This session will be taken up by most esteemed guest speaker, Mr. Suman Devnath. Mr. Suman is currently a principal developer advocate at Amazon Web Services, and he is a very frequent speaker at many national and international conferences like PyConf and GHCI. So, with his technical experience and knowledge, he'll be guiding us through the world of cloud computing and AWS. So, without any further ado, I'd like to welcome Mr. Suman Devnath onto the stage.
Hey, thank you, Kushwanka. Thanks so much for your warm welcome. Glad to be here.
Welcome, sir. It is a pleasure to have you with us today. We are really excited and looking forward to this session. So the stage is all yours, sir.
Sure. Thank you so much. So let me first share the screen and then we will get started. Give me a moment. Okay, can you let me know if you are able to see the screen? I hope yes. Right?
Yes, sir. It's visible.
Okay, perfect. Okay, sure. Firstly, thank you so much for having me. It's such a pleasure to be with all of you. Hackathon is always very important for us, even at AWS, and especially when a student community and energetic people like you develop something unique. It's always motivating to older guys like me who used to spend useless time during their college days, right? So I'm one of the backbenchers in the college days, and I still feel that if I could go back to my college days, I could do something meaningful. So thank you so much for your time. I know this is a weekend and this is an evening time. You have much more important things on the
Yes.
table rather than learning this particular topic. But I'll try to make use of this 1 hour so that after 1 hour, you get something out of it. Okay. So what we're going to do is we'll touch base on few of the things around serverless and cloud computing, and we'll spend some time on the hands-on. There is some machine learning also. We will try to explore, and we are going to show a small demo with serverless and machine learning. Okay, so. Before we get started, my name is Suman Devnath. I'm a developer advocate at AWS. I joined roughly around 1 year, 9 months back at AWS. Before that, I used to work for various other companies like EMC, IBM Labs, and so on. And I'm basically from Calcutta. I'm in Bangalore for last 8, 9 years. And I guess being in the cloud, world or at AWS, it gave me a immense opportunity to interact with student community. Right. So feel free to reach out to me after the session or during the session over LinkedIn or Twitter, wherever you feel like, and ask questions. Not at all related to serverless, but anything around getting started or career or jobs, internship, whatever it is, and obviously the hackathon. Right. So I mostly focus on storage and machine learning, and that is the area that I'm predominantly focusing on for last couple of months. But feel free to reach out to me for anything around cloud computing. So let's first understand what is cloud computing. If you are already aware of cloud computing and serverless computing, then it might be a repeat. But maybe you will get some perspective around how serverless computing works on AWS. Okay, and then we'll quickly get into the architecture part. But I'll not bore you with the slides. We'll straight away go to the demo and see something hands-on, which will I guess that will resonate well. So let's get started with serverless. What is serverless? So from the term, it's quite misleading. It sounds like there is no server, but it's not like that, right? So we cannot run anything, without hardware, right? But it's just like you don't have to rely on the hardware. Okay, so all you have to do is you have to focus on your code, your application, and there will be someone in the back end who will provision the hardware for you. Okay, so we are going to see that how it all works. But serverless is basically you get rid of all the nitty gritty of servers, networks, and all of that memory and all of that in the back end. Okay, and what you just focus on is on your code. Okay, so and we are going to see that in action, how you can convert your application into a serverless application going forward. But what are the advantages? Yeah, there is no server to provision, and it can scale massively, right? And that is very important. Like I'm sure that during your college days, or even while you're participating in this hackathon, there might be a lot of ideas that you had, and you're working on something. During a point, while developing or while solving that problem, you might have realized that, hey, this is not working. Let me start from scratch, right? So just imagine if you have purchased one hardware to build some application which you have initially thought of, and during the midpoint you realize that, okay, this is not working. I need to pick up some new idea, and for that I need a bigger hardware or whatever it is. In that case, you have to sell that existing hardware, right? So you have kind of a binding on your investment on the hardware, right? So that's why it is not that manageable and scalable, in the sense you cannot fail fast, and with serverless you can fail fast and learn from your failure and go ahead, right? And also in terms of scaling, because today if you look at it, like now IPL is about to start, right? So now if you log into Hotstar app, you will see that there might be few thousand people or even a few million people watching that game. But let's say during the last 3 overs or 5 overs, the traffic might increase 10 times or 100 times, right? So imagine that if you had the infrastructure in a completely on-premise or completely non-serverless fashion, then how difficult it is to manage that scale, right? So serverless computing can help you to scale your application to almost not infinite, but you can scale it as much as you want, and you don't have to worry about the hardware infrastructure in the backend. And it's always highly available and fault tolerant. You don't have to worry about all of that. But the idea is, since you are just focusing on the code, you don't have to worry about the high availability and fault tolerance. It's already, your code is already redundant across multiple places, so that the infrastructure in the backend have the are highly available. So you don't have to worry about the availability or failure of the hardware. So there are a lot of things that a lot of services that we have at AWS which are serverless, but the most predominant one is Lambda. So there are many other services which works in a serverless fashion, and they are serverless based services. But AWS Lambda is the core of it. Okay, so what is AWS Lambda? You run your code without servers. You just pay for your compute time, and Lambda takes care of everything like scale, high, HA or redundancy and everything. Okay, so we are going to see how Lambda works. So if you are aware of Python, these two lines of code would be very familiar to you. But even if you are not from Python, you work in Java, C++, or .NET, whatever. Just imagine some function. Okay, so in this case, we have a function like handler. It has two parameters or arguments, event and context, and it returns hello world, right? So now let's see that how a Lambda function works. So what you do is you define a Lambda function, and this event is basically the data about what triggers the invocation. So I did not introduce you to the word trigger, but when you think about Lambda function, you can imagine that think of an application which gets triggered based on some event. Let's say, if I give you an example, let's say you want to convert all your text file or your Word file into PDF, right? So oftentimes what you will do is you will go to a internet and search online tool to convert document to PDF, right? We often do that. And then we will end up into one of the website where you have to, they will ask you to upload the document, and within a second you will get a PDF converted, right, in your laptop. Now imagine that you are a developer of that company who built that website, right? And if you look at this particular problem, the problem is very simple. Whenever a user uploads and file, you just have to convert that into PDF. That's all. That means your code should run only when there is a trigger. And in this case, in this example, the trigger is nothing but uploading a file, right? Whenever the code receives a file, it should execute, right? So this particular problem is a very good example of converting it into a Lambda function. Because let's say without serverless, what you would have done is you would have written the code and would have deployed it in some server and kept that server on, right? And even if no one is uploading any document, you are still built, because your power consumption, your compute, everything should be up and running. Even when you are sleeping, your server should be up and running, right? But imagine that if you convert this application into a serverless as a Lambda function, what you can do is you can write your code, and you can in that code, the event would have been uploading a document, right? So maybe user will upload the document and save it in somewhere, and that will actually trigger this particular function, right? And in this function, you will write the logic of converting the document into a PDF, right? So this event is nothing but contains all the information about that trigger. So whenever someone talks about serverless, always think about any application which should be invoked based on some trigger. You can think about Lambda function, right? So your application should be trigger driven, okay? And we are going to see that how it works, in the real world. And there is some another argument called context, and the context, it's kind of a metadata. It contains all the runtime information, like at what time it got triggered, who triggered that, and all of that. So this function will return something, and that will go back to the user. So in our previous example, this return would have been a PDF document, right? So this is how a Lambda function works. So how to run that Lambda function? You just save this into a file called, let's say, app.py, and then you just install Python. Obviously, you have to install Python because this is a Python code, and you will run it like this, right? Import app.handler, whatever you give. Here we are just giving nothing, kind of an empty dictionary. But the reason that we are passing it empty is because if you look at the code, it doesn't take anything. It doesn't do anything basically, right? But it's just to show you how you can run a function within your Python interpreter, right? Now imagine that you convert this code into you are not running this code in your laptop, but as a Lambda function on AWS. So what you have to do is first you have to install AWS CLI, which is the command line tool to access any of the resource on AWS. And then you have to configure AWS with the username and password. So basically access keys. We don't call it as username and password. There is some security access key and identity access key, which you need to configure with. It's very similar to how you configure GitHub in your desktop, right? So once that is done, what you can do is you can use AWS CLI to create that Lambda function. So the syntax is very straightforward. AWS Lambda create function, and then you give some function name, let's say hello, and then this is the handler. So what is the handler? The file name app dot handler, because handler is the function name, right? And you also define the runtime is Python 3.6, 3.7, 3.8, whatever it is, and then you have to give some role. So in AWS, everything is around roles and permissions, because your Lambda function need to access some resources, right? So you don't have to worry about that as of now if you're new to AWS. But role is, you can think of it as a permission identity. Okay, so this you need to define, and this is basically in the backend. This is actually a JSON file which contains all the permissions that you want to grant to this Lambda function. Okay, so we are going to see that in later, that we are going to create a Lambda function which will read a file, and it will use some machine learning service, AI service, to analyze that text in that file. So in that case, the Lambda should have the permission to talk to that machine learning API, right? So we will add that permission in this role. Okay, we are going to see that in some time. And then you have to give the code itself. So the code you have to, here it's app.py, but before you run the CLI command, you need to zip that, because it might so happen that your code might use some third-party libraries like import Torch or import TensorFlow and all of that, and you need to install that, right? So you might have a requirement.txt file, and all of that you need to package it in a zip file, and that's what the location of the zip file is. Okay, so once this is done, what happens is from your laptop, that code will go to AWS. Okay, and it will create a Lambda function, and once that is created, you can invoke. How you can invoke? So in this case, we are just doing a manual invocation. That means we are just putting a trigger, right? So how we are invoking? We are saying AWS Lambda invoke. Then we call the function name, which is hello, and we are saving the output in a file called output. Okay, so what this function should return? It should return hello world, right? So if you now cat output, you will see hello world. Okay, so that's how a Lambda function typically works. Now let's take some input argument, right? So here we are actually using this. Previously we used to say, we have said, if I go back, it used to say return hello world, but now we are going to read some information from event and do something. So what we are doing, we are actually expecting that event should have a hash called foo, and then we will just convert that to uppercase. Okay, so now let's trigger this. So how we can give the input to this Lambda function? We can invoke it in a similar way that how we have invoked before. If you see Lambda invoke, and then the function name is hello, but the new thing is this payload. Okay, so here we are saying that this should be sent to the Lambda function, and this is nothing but this part, right? This payload, whatever we have given, this will go in the event, right? So this is the data that the user is sending. So in our previous example, this would be your Word document file. Okay, and we are going to see that in some time. So the foo, then what it will return? It will check event foo, which is nothing but a bar. And what we are doing, we are using we are converting into uppercase, right? So, and then it is again saving the output to output file. Okay, so now if we just do cat output, you will see bar, right, in caps. Similarly, now after some time, or at the same time, if you send another invocation, but now you send bars, then you will say bars, okay, in caps. So you're getting the idea, right, how this all things work. Now, important thing to understand is you have not deployed this application anywhere, right? So you don't know where it is running, how it is running. All you have done is you have written this code in your laptop and you have just pushed it to AWS. And now whenever there is an invocation, AWS is provisioning something. We don't know as of now what is that, but it is provisioning some infrastructure for you, and it is returning you the result. Okay, so now let's look into how this Lambda function internally works. Okay, so what happens is after you create a Lambda function, nothing happens on AWS. But the moment you give the invocation, this is the first time you are invoking, right? This is the first time you are invoking this Lambda function. So what happens is AWS will download that code, what you have, you have in this function, okay, and then it will start a container. So if you are aware of containers, which is a runtime environment, basically, uh, you should not think about container as a virtual machine, but it's a very lightweight runtime environment, right? And it has all the libraries and dependencies to run your code. Okay, if you are aware of Docker, or if you have worked on Kubernetes, then I'm very sure that you are aware of containers. Okay, so if you want to know more about containers, we can talk towards the end, if time permits. But for now, you can imagine that it's a small runtime environment which will go away once the execution of the code is over. Okay, so, and this is very fast. It's not like it doesn't have a fully blown operating system. Okay, it's actually a container is created on top of some machine based on the runtime that it has. Like Docker is one of the runtime. So that's why what we do is whenever we want to use Docker, we install Docker in our laptop, and then we can create containers as and when we need it on our laptop, right? So it is very, very fast. So on AWS, it will first download the code, it will start a container, and then it will bootstrap the runtime for you, which is a Python 3.6 or 3.7, whatever it is. For in our case, it is 3.6. So it will count. That's why this is for this particular stage, you need to define what is the runtime, because AWS won't be able to understand the code that you have written is of which language. So you have to define the runtime, Java, .NET, Golang, whatever it is. Okay. So once that is done, it actually starts to execute. Okay, so this is when you are doing it for the first time. Okay, now if you can imagine, the initial 3 stages: download the code, start the container, and bootstrapping. This takes a lot of time, but actual work has not yet started. That's why we call it as a cold start. And after that, the execution of your code is very fast, right? Now what happens is, let's say now you send a second invocation. Now we are giving, let's say this we invoked at 7 p.m. and this at, let's say, 7:01 p.m. Okay, and let's imagine that within that 1 minute, this cold start is executed. Okay, this is already done within that 1 minute. So what will happen is, the next time when you execute this, okay, it will just take a very small amount of time because the container is already ready, right? So that's why we call it as a warm start, because your container is already there on AWS, and it will just run the code again. Okay, but let's say you are not using enough invocation. Let's say the first invocation came at 7 o'clock, and let's say till 7:30 there is no invocation, right? So again, the AWS will not waste its resource, right? It will dismantle that container, and whenever there is a new invocation, it will again start from cold start, and it will do the warm start. Okay, that's how it works. But the idea that I want to give you, or the intuition that you should have, is for the first invocation, it takes a little bit of time. So it's a fraction of time. It's not that significant. But second time onwards, it's very, very fast, right? And that's what we say, that this is very much scalable, because no matter how many invocation that you put, AWS can manage that. It might create multiple containers for you to support all the requests from your user, right? So it might so happen that 100 people are accessing your Lambda function at a time. So in that case, there will be 100 containers will be created. Right? So there is a different topic. We have something called concurrency, but it's an advanced topic. But the idea is you can do that with serverless. Okay, so now the last topic that I had was how what are the different types of invocations that we have. So as I mentioned, whenever you think about serverless or Lambda, you should think about any application which are trigger based. Okay, so the trigger can be anything. One of the example that we gave is uploading a file. That means whenever there is a file upload in some place, the Lambda will get triggered, and we are going to see that in the demo. But it can be anything. Like it can be a timer, a scheduler. It can be an SQS message. So these are the different AWS services, Amazon API Gateway, SQS. These are all different AWS services. Okay, so the way that you should think about AWS is it's a Lego based company. You can think of it like that. I mean, Lego, I'm very sure all of you know about it. And when you build an application, you have to stack different blocks to make something meaningful, right? So you just have to integrate different services from AWS so that it can work well with Lambda or any other service, right? So we are not going to go into details of Amazon API Gateway or SQS, but in a layman's term, API Gateway is nothing but an API-based service which can take a request from your end user, and it can send the request back to the backend resources, and like you can have a get request, put request, post request, whatever it is. An API gateway can seamlessly take that request and provision it to the backend, right? So that's about the trigger. And then Lambda function is actually the code that where you write the actual code or the logic of your application, and then Lambda function will send that output to somewhere, right? So it can be a database. So DynamoDB is a NoSQL database service from AWS, or it can save some data to an S3 bucket. So Amazon S3 is an object-based storage, which is nothing but a storage service where you can just dump your data. Okay, and we are going to see that in the demo. But S3, you can compare it as it's not a fair to say compare, but if you have used Dropbox or any service like that, you can think about S3, like that. Okay, but S3 can do a lot of things than what other cloud storages can do. But Lambda function can execute the code and save the result to a database or to an S3 bucket or anywhere. Okay, and we are going to see an S3 bucket in our demo section as well. Okay, so that's about it, and I feel that we should get into the demo, but I guess there is one more slide that I want to show you. I'll just quickly go over that. Whenever you have multiple invocation, your Lambda function can deploy in multiple containers, right? So as I mentioned, right, if you have multiple events coming at the same time, AWS will provision different Lambda functions, I mean multiple Lambda functions, so that it can adhere to the scale that is needed. Okay, so the way that it works is you send an invocation, the Lambda function will execute the code and it will send it back the result. Okay, an example would be an HTTP API request. Let's say you want to know all the users in your website or in your application, and it will trigger a Lambda function which will fetch the data from some database or wherever it is, and it will your REST call will wait for this response, right? And that's why we call this invocation as synchronous, right? Because this is happening synchronously, so it has to wait for this whole cycle to complete. There is an asynchronous invocation as well, where let's say you just upload some file and it just say, okay, upload is done. So uploading a file is kind of, you can think of you have an image, you just upload it into an S3 bucket. Okay, and after that, the moment there is a file in S3 bucket, we have created a Lambda function which should get triggered. So the Lambda function will get triggered the moment it sees a file in this S3 bucket. Okay, and then Lambda function might do something. So in this case, let's say Lambda function will take that image from S3 bucket and it will generate a thumbnail. And once the thumbnail is generated, it will save that file thumbnail image into this S3 bucket again. Okay, and then this S3 will give a response back to Lambda that, hey, I'm done with the upload, right? So this is an async event because the user has just uploaded the image. That's all, right? And it got the response. Now, if he has to see whether the image got the thumbnail or not, he can come to this bucket and see that the image is generated the thumbnail or not. I mean, Lambda function has generated the thumbnail or not. Okay, and we are going to see similar demo today, where we are going to upload some text file, and the Lambda function will read the text file from S3 bucket, and it will use an AI-based service to get the sentiment of the text file. Okay, we are going to use some AI capability from AWS. Okay, so let's get to the demo part. I don't want to continue with the slides. I guess this is enough. So if you have any questions, feel free to ask in the comment. I guess there are a few questions before I get into the demo. I'll just go over that. So, okay, sure. Yeah, someone asked, how can we invoke one Lambda function to another Lambda function? That's a very good question. So you can always do that. So you have one Lambda function and it is triggering another Lambda function. You can always have this cascaded triggers. And I'll show you when you create a Lambda function, how it asks you to mention the trigger. So you might get that a little more clear. Okay, what are the restrictions applied to Lambda function code? That's a very good question, Akriti. So as you might imagine that Lambda function is for short-lived processes, right? So you cannot have a very huge application, running on Lambda, because Lambda is kind of, you should have a Lambda function to do one such activity, right? And it should be short-lived. And one of the things that I wanted to highlight is there is a limit for the memory. Like if you have a Lambda function which needs, let's say, 1 terabyte of memory, then probably either your application, you need to think about it to rectify, or you should not use a Lambda function, right? So one example would be, let's say, if you're into machine learning, you know that in machine learning we do a lot of training, and training needs a lot of data, right? So that data might be in GBs and even in TBs, right? So you should not train a model as a Lambda function, right? So you should have a virtual machine, or you can use some other service on AWS like SageMaker to do that training for you, right? So one of the limitations is that you can have a maximum of 10 GB. So previously it was not even 10 GB, it was quite less. But recently, in I think last year itself, we maximized that to 10 GB. And also, one of the other thing is Lambda also have a limitation in the form of time. So a Lambda function, I guess it was 15 minutes. I'm not very sure about the exact number now, but your code should get executed within 15 minutes. Otherwise, it will be timed out. So you cannot run a long-running process as a Lambda function. In that case, Lambda might not be the right solution for you, or you might want to break your application into multiple small Lambda functions, and each Lambda function will do its own job. So you have to think about a microservice-based architecture so that you can accomplish your task, right? So those are the few design things that you need to think about. And as always, right, it's not about AWS Lambda, but whenever you learn some new service, that cannot replace everything that we have today, right? So there's always a different use case for this, but you have to understand what are the trade-offs, right? But I guess you got the intuition of where to use a Lambda function. First is wherever you have an application which is event-based, like wherever you feel that your application should run based on some trigger, then you should think about Lambda. And another is your application should not be very highly memory, eating application, right? So because you have a memory limit on AWS Lambda, right? And the other thing is you will be charged based on the invocation, right? So there are a lot of, I think, in the free tier, you will get a lot of invocations for free. I guess it's more than 100,000. But over the period of time, you will be billed based on your invocation. So if no one is using your Lambda function, you won't be charged. So that's the beauty of serverless. Okay, so what are the other questions? What kind of code that we can run in the Lambda function? Okay, Sachi, we'll see that in a moment. How secure is serverless cloud computing? How it maintains the security of the user? That's a very good question. One thing that you should realize that at AWS, whenever we launch any service, security is the topmost flag that we have, right? So we do not host, or we do not release any service which doesn't qualify the security compliance, right? So you don't have to worry about from encryption to your data. Everything is completely secure. No one can access anything in your account on your behalf, right? So in fact, no one even knows, even at AWS, that where is our data centers and all of that, right? So it's very much a compliant, and all the services are compliant with the respective security compliance organizations, and these are used at various places like defense, then what is that? Research organizations and government organizations. So you can understand that their hardening around security is much more than any other place, right? So it's very much secure. This is from your data perspective, but from the user's perspective, you control everything with IAM. So you have seen that role that we use to when we created a Lambda function, and you can harden the rule as much as you want, right? So you can specify who can access this Lambda function, or who can access a particular resource, who cannot access, who can access at what condition. You can define everything, right? So each and everything is around IAM. So this is the service, Identity Access Management, and this controls everything within AWS. Okay, so now the first thing that I want to show you is I want to show you a few of the machine learning things. Then we will get into the Lambda part, because we are going to use a few of the AI-based services. So in AWS, if you scroll down, this is the login screen of AWS console. If you have never logged in, you can create a free account, and you can get started with it. As a student, if you have a college ID, you can make use of AWS Educate. Okay, you can make use of AWS Educate, and you can create you can click on Join AWS Educate and create a account for you using your using your college email ID. It won't work with your Yahoo, Gmail, or Hotmail, or any of these free email accounts. You need to have a college email ID. If you have that, then you can create an AWS account, and you can get started free of cost without credit card. But if your college doesn't give you any domain or email ID, then you need to create an account, and that needs a credit card. Okay, although you will not be charged for the first year. There are a lot of services that are free for first year. We call it as a free tier, and whatever we are going to see now, those all comes under free tier. So you can always make use of these services. Okay, so one thing that you can understand from here once you log in is we have lots of services, right? Like for container, for storage, for compute, and so on. But you don't have to overwhelmed with this. You have to just pick the things that you want for your application or for your work, right? So we're going to see a few of the AI-based services that we have, and one of the service is AWS. Where is that? Amazon Comprehend. Okay, so we are going to see Amazon Comprehend. So Amazon Comprehend is a service which is used for any NLP based task or natural language processing task. Okay, and there are other services that we have, like Amazon Recognition, which is for any video or image related analysis. Okay, so let's say you want to detect that an image contains what objects, like maybe image contains a hotel room, or an image contains a human, or an image contains an animal, whatever it is, right? So you don't have to write your code to train a model, deploy a model, and all of that. All you can use is you can use Amazon Recognition, which can help you to do all of that. Okay, so similar to Recognition, we have another service called Amazon Comprehend, which can be used for natural language processing and text analysis. Okay, so since most of you are in the college and you are, most of you, I'm sure that you are, aiming for a dev-based role. So I'm very sure that UI may not excite you. So what I've done is we are going to see that in the SDK how it works in the command line. But in the UI, it's very simple. You have to just launch Amazon Comprehend, and you can put some text and click on analyze, and it will analyze all the entities. Let's try it out. Let's say thanks for joining this session. Okay, and I'm just clicking on analyze. So what is happening is the moment I click on analyze, from this UI, it sent an API request to the comprehend service, and it it returns some response. So let's see some of the response. In this sentence, there is no entity. That's why the result is nil. There is no entity displayed. Let's see key phrases. There is no key phrases in this language. This is an English language sentence. PII is a personal information. There's no personal information as such. Sentiment is something interesting. So this sentence is a positive sentiment. This sentence has a positive sentiment. So that's why we see that it's positive, and the confidence score is almost 99%. So it's very certain that this sentence is a positive sentiment, right? And you can also see syntax like thanks is a noun, joining is verb, and so on, right? So these are the things that you can do using comprehend. And just imagine that I have not written any code to do the training for this model, right? So all I'm doing is I'm using an API to call this comprehend. Okay, so in the backend it is using an API, but let's see how you can use those APIs through command line. Okay, so um, I have opened a Jupyter notebook, and this is not the Jupyter notebook on my laptop. It is on SageMaker. Okay, so let me just show you that. So let's say if you go to SageMaker, so SageMaker is another machine learning service. So let me go to the home page and show you. If you come scroll down, and under machine learning, you will see SageMaker. Okay, so SageMaker is the place where you can actually write your code, deploy, build, and train your models. And all other services are API based service where you don't have to write much of your code. You just have to use that. But if you go to SageMaker, you would see that there is an option called notebooks. And if you come to notebook instance, you can create your own notebook. So what do you mean by notebook? It's just like a Jupyter notebook, but it has all the frameworks like, or rather packages like PyTorch, TensorFlow, MXNet, and so on. All are installed, right? So you don't have to worry about installing and configuring and all of that. So you can just get started with it. So similarly, for this particular demo, I'm going to use this particular notebook which I've created long back, and I just clicked on Open Jupyter. The moment I click on Open Jupyter, I will get into this home directory. Okay, and this is the folder that I've created. And if I go inside that, there's an AI service notebook, right? And why running notebook on SageMaker is good, because if you now click on new, you see that all these kernels are available. Now, if you have used a Jupyter notebook in your laptop, if you open, you will probably see Python 3 or Python 2, right? But here you see all those packages or runtimes. So that's the advantage. And also there are some example notebooks available, and you can preview them. You can use them. The moment you click on use, that particular notebook will be saved in your present working directory, and you can get started with there. Okay, so SageMaker example is also new, which is not there in your local when you use Jupyter notebook in your local environment. Okay, so enough about Jupyter Notebook and SageMaker. So let's click on this AI services, which I've already opened here. And now let me just increase the font a bit. Okay, so now we are going to see a few of the functionalities of Comprehend, right? What we have seen in the UI. So first is you need to install Boto 3. You don't have to install. It is already installed because I'm using SageMaker Notebook. This is pre-installed. But Boto 3 is the SDK. This is the Python SDK for AWS. Like whatever you access through on AWS using Python, you need to use Boto 3. Okay, and then why I'm using this, because I'm going to use Comprehend, and we are going to use Boto 3 to create or call that API for Comprehend. Okay, and we are also going to use JSON library and pretty print. It's just to nicely print a JSON file. That's all. Okay, so let's see, comprehend, how we can call comprehend and how we can make use of that. So although there is 10 lines of code, but actually the API call is just one line. This is and that is line number 6. Okay, so let's see, what we are doing here. So we are writing a small function for getting the sentiment of a given sentence or a given text. Okay, so we are just creating a small wrapper function. This is a small wrapper function. You could have done this without this wrapper function, but just want to show you how people generally use it. So first is you have to call Boto3 client, and you have to give the service name. So since we are using comprehend, we are giving comprehend. But let's say if you want to do a recognition for some image, you will say recognition. Okay, so in that way, you will have this client as a recognition client, and then you can pass an image to this client to get some information on that image. Okay, so let's change it back to comprehend. And once you have this, then what you can do is you can just call detect sentiment method, which comes with this comprehend class, right? So the moment you call this detect sentiment with some text and the language, you can skip that, but we're just giving this an English language. And then this is just for, since we are using JSON dumps, we are just trying to make sure that it has the right indentation when we print it. And then we can dump that data using JSON dumps, and we can load that data back, and we can see the sentiment, and we can also see the sentiment score. All that, the result of this is stored in our raw data, right? So let's run this function. And now let's say the text that I'm going to pass is I love Amazon Web Services, and let's see what we get in the sentiment. Okay, I guess I have not imported this. And now let's run this. So you see that it says that it is positive sentiment, and the percentage is almost 99% positive. This is the confidence score. So let's try something odd. So let's say I say I hate you. Okay, so let's see what is the sentiment that we get. It's almost 97%. It's saying that it's a negative sentiment. Okay, so this is how easily you can use the API based service, right? So now let's see how you can make use of detect the language, right? Similarly, again, it just this single line is different. Rest all the lines are almost same. So we are calling detect dominant language, and we are passing the text, and we just want to see that what language the text is. Okay, so here again we are passing some text, and you see that the language is EN, which is nothing but English, right? And the confidence score is 93%. And let's try with some Hindi text, and here you will see that the language is IN Hindi, sorry, HI Hindi, right? So all that is happening is in this case, if you see, I'm printing this, the whole output here. I'm printing this whole output just to show you, how that raw data, looks like. And after that, I should have commented that, because the reason that I printed is because to write all this next two lines of code, because how would I know that, the actual language is inside this language code, which is nothing but the first element of this list, right? So that's how I came to know about this location, right? So always, what you will generally do is you will just you'll not have anything. You will just first print this raw data, and you will see, understand, how that output looks like, and then you will write the following code. Okay, so now that we have learned how you can detect the sentiment, how you can detect the language, now let's see how you can detect a batch of sentences. So here we are sending two sentences. Machine learning is fascinating, and there is some Hindi sentence. And here we are calling batch detect domain language, right? And we are sending not text, but text list. If you scroll up and you see that previously we used text, now we are using text list. That means we are going to pass a list of text, right? So now let's see how that output looks like. So since it has two sentences, the first sentence it says it's an English language, and second is saying that it's a Hindi language, right? So I just want to give you an intuition of how you can make use of any AI-based services using Boto3 or Python. Similarly, you can use Java SDK or .NET SDK to call these APIs. But the idea is you're not writing any single code to train your model, deploy your model, or build your model, or anything of that sort. You are a software developer, and all you need is to make use of AI in your application. That's all, right? So this is the only single line of code that you are writing, and before that, you have to just use Boto3 to create an object of that respective service, right? So now let's see, what we are going to do with the Lambda function, right? So what we are going to do is we are going to create a S3 bucket, okay? And S3 bucket is nothing but a place where you can just dump your data, and bucket is nothing but you can think of it as a folder, and then you dump your data inside that, okay? And S3 bucket are unique across the globe, so you cannot have a common name. You should have a unique name, and it's not only within your account, AWS account. It should be unique across the globe, right? So if I try to create a bucket called India 2021, probably this might be used by someone else because it's a very common bucket, right? So what we're going to do is we are going to create a Lambda function which will get triggered the moment there is a text file upload, in this bucket, and then it will call comprehend, and the comprehend should read that text and tell us all these sentiment or language and all of that, and we are going to see that Lambda function how it looks like. Okay, so first thing is we need to create an S3 bucket of this name, which I have already created, but I'll just show you. So let's go to S3. So S3 stands for Simple Storage Service, and I have almost 41 buckets. And if I just search for this, there is a bucket here, right? And there is no file inside. But how you can create a bucket is very simple. You click on Create Bucket, and you give some name. So let's say I give some common name, let's say India. And you just scroll down. There's some configurations like tags, bucket versioning, and encryption. Let's skip all of that for now. But if you click on create, it should create that bucket. But as we expected, this is a very common name. But let's say we add some random numbers to that and then try to create. So now it got created, right? So it created a bucket, right? It doesn't have any file, but it has created a bucket. All right, so now we are going to use this bucket, and we'll come back here later on because we have not yet created this Lambda function, right? So let's go back to the notebook just to see where are we. We have created this bucket. Now we have to create this Lambda function, and this Lambda function is S3 trigger, right? So let's go to AWS console and go to the home page. And if you come down, you will see Lambda here, right, under compute service. But you can always search for Lambda here as well, right? So I'm not going to click here because I've already opened, the Lambda service here. So when you first enter the Lambda console, you will get into this, welcome screen, okay? And you can create a function like this. Let's say create function, and there are different options available. Scratch from author from scratch using some blueprint, or even you can give some container if you have already built, or you can use some repo. Okay, so let's select author from scratch. We can give some name. Let's say demo 123. You can use the runtime. So I guess someone was asking what are the language that it supports. These are the other languages that it supports: .NET, Java, Node.js, Python. In fact, I think Python 2.7 is recently, we are about to deprecate that, but it still is in use, Ruby and all of that. Okay, so you can pick the language of your choice, and then you can just click on create function. Okay, the moment you click on create function, inside that you can write your code. Okay, so if you remember in the slides, let me go back to the slides. If you remember that we have created this Lambda function using CLI, and we have given this function name and the app.handler, because this is the function, and the runtime, right? So now we are doing it exactly the same thing using UI, right? So if you now come to the UI, this is the Lambda function. Now there is no trigger yet. This Lambda function is, there is no code here. If you just double click on this, you can write your own code here. Okay, and we are going to write some code here to call that comprehend. But this is where you will write your code, and you can come here and save it, and then you have to deploy it. Okay, and the other thing is you need to add some trigger, right? So you have to click on add trigger, and here you can put all those triggers, what it should trigger. Okay, so there are different services that you can use that it will be used to trigger your Lambda function. Okay, so this is how the overall in quick time. I just want to show you how a Lambda function is created through UI. Most of the time you will not use UI. You will be using some a tool, like we have a tool called SAM, serverless application model, which is based on CloudFormation template. And CloudFormation is nothing but a service that we have for infrastructure as a code. If you want to write your code to deploy your infrastructure, you use CloudFormation, and SAM is on top of CloudFormation. So it actually internally use CloudFormation, but SAM is dedicatedly for developing API serverless based application. Okay, so we are not going to go there, but that is something we can have some separate session, or if you're interested, you can ping me offline. But this is how you will deploy your code into your production. You add a trigger, you write your code, and you add some destination. Okay, so I'm going to go back to the function, and there is a function that we already have called S3 trigger. And if you come here, we already added a trigger for S3, and we have added a trigger for CloudWatch. Okay, this is just for logging purpose. But how you add this trigger is, as we have seen before, we are going to see the code a little later, but you click on add trigger, and we know that for our problem, if you remember, the Lambda function should get triggered the moment there is a file in this bucket, right? And what is that bucket name? Bucket name is Techna 2021, right? So now if you come here, you have to select S3, right? And the moment you select S3, it will ask you for the bucket name. So it is Techna 2021. And what should be the event type? We want this event to trigger the moment there is a new file, right? So all file create event, right? And then you can also give some prefix if you have some folders inside that bucket we don't have. You can also say that, hey, you should trigger only when there is a file with an extension of JPJ, okay, or PNP, whatever it is, right? So since this is we are going to use comprehend, that means it cannot analyze any image, right? So we can always say that the suffix should be .txt, right? It should not trigger for any zip file, right? It should not get triggered if someone uploads a zip file or someone uploads an image, right? So you can always make use of this suffix. Okay, and then you can just acknowledge and add this trigger. Okay, we are not going to do that because it already having a trigger. If you click on S3, you will see that this is the S3 bucket that it has. We have selected as a triggering mode. Okay, so now let's go to the code, right? So click on code, and let's click on this Lambda function, and let's read this code. Okay, now this code would be very similar to what we have already seen, and that's the whole point why I shown you this this notebook first. Okay, so now we are going to use same Lambda handler, event, and context, and we are going to create a S3 client because we are going to read the data from S3, right? So if event, that means whenever there is an event, and we are going to do some operation, right? And what is the operation? We need to read the file from your S3 bucket and call the comprehend function. So we are defining the bucket. The bucket name is Techna 2021, and we are just reading the record. So now, how do I know about this particular event records 0? Again, I have just printed this event, how it looks like, and then I got to know that, okay, this is the place where I actually know the object name. That is nothing but the file name, right? So we are just printing the file name as well in the log, so that we know that our event is getting triggered because of the file that we are uploading. And what we are going to do is we are going to call comprehend, right? So this is where we are calling comprehend, and then it's very straightforward, right? we are calling detect sentiment, we are calling detect entity, and we are calling key phrases. So key phrases we have not seen in the Jupyter notebook, but it will just detect the key phrases from your text. Okay, and then all these results, we are just printing it on the console, not on the console, but on the logs. So we are just have these print statements, and we are going to see that in the logs whether this Lambda function is getting executed or not. Okay, but in the real world, it won't be we are not going to print that in the console, but we are going to save it in some other file, and that file will be saved in some S3 bucket again. Right. So in that case, we will add some destination, and after this the Lambda function execution, it will save that result into that destination. Right. So now let's try to execute. Okay, so what we are going to do is we are going to upload some file. So let me see where I kept that text file. Give me a moment. Now, I guess inside this. Okay, there is no such file. Where is that file? Okay, yeah. So here is one file. So let's see what this file contains. Uh, okay, you guys are amazing. I'm happy to meet you all today. Okay, so let's upload this file in our S3 bucket, right? So let's go to S3. And let's go to that bucket. Okay, and now we can just upload. So we can either click on upload, or we can just drag and drop. Okay, so let's upload. It's uploading now. So it got uploaded. So now we see that there is a file called sample text dot text. So ideally, now it should trigger that Lambda function, right? So how we would know that? We can go to the Lambda function and click on monitor, and we can click on. We can also see the invocation in last 1 hour, 3 hour, and so on. But we can also see CloudWatch. So this is the logging service that we have. All the services that we have in AWS gets logged into CloudWatch if you have configured it in that way. And we see that there is a trigger, and let's click on that. And if you see, where is that? Is it a trigger? Let me click on this. I'm seeing the right log. Just give me a moment. Okay, so it looks like there is some error, and let's see if we can identify that error or not. So this is the bucket name. Everything looks fine. Okay, so now let's, where is that? Just closing this CloudWatch. Just close this, close this. We are going to click on monitor. And click on CloudWatch. And okay, let's line number 15. It says records. Did I just did I use any typos or anything? No, right? I guess no. Okay, let's try this. Can save this. Can deploy that, and let's try to delete all of these logs so that we have a clean slate. Okay, so now what we can do is we can come to S3, we can delete this. Even without deletion also it should work, but let's try to delete this. And let's try to upload. Oh, sorry. Upload, add file. Okay, so it got uploaded, and let's now refresh this. Come to monitor, and now let's click on CloudWatch. Looks like a stream. Yeah. So now you can see that we have just printed the print statement. That's why this whole print has come here, right? And then it says that what is the sentiment? This is the text file, right? Sample.text, sample underscore text. This is the sentiment, right? This is the sentiment, and you can see that this is a positive sentiment. It also says the entities. If you expand this entity, you will see there is a date entity, which is nothing but today, because the sentence is, if you remember, the sentence, sorry, what was the sentence? The sentence is, I'm very happy to meet you all today. So today is a date entity that already identified, and then there are some key phrases like guys and so on. And not only that, it also tells you what is the offset, like from which character that starts and which character it ends, right? So this is how you can make use of different services, like we have seen here. Like we have seen here, how you can make use of S3, Lambda, and Comprehend all together to build something meaningful, right? So that's what I want to show you. And if you are interested to learn more about serverless, you can go over the AWS serverless workshop. If you want the link, I can share it with you. But you can just Google it, AWS serverless workshop. And also there is a nice website which was built by one of our teammates, and you can call all of these AI-based services from your console, right? So you don't have to have a AWS account, but this is just a website just to showcase, how Comprehend, Translate, and all of these different services work, right? So recognition, as it's a service which we use for image analysis or video analysis. Comprehend we have seen for natural language processing. Similarly, we have Poly, then transcribe and translate and so on, right? So just have a look. I'll just paste this link in the chat. Okay, so that I don't think I have. Okay, I've just sent it to the organizer. Maybe if they can help you with the site. Okay, so that's all about it. And I have what I'll do is I'll go over a few of the questions, and then I have a question which I'll ask you, and then I'll hand it over to organizer. Okay, so I know that I'm already over the time, but just a couple of minutes. Okay, I'll just go over all the questions. Okay, so there's a question: what is the relationship between an instance and AMI? Okay, that's a very good question. So AMI instance is nothing but, and if you see instance, nothing but EC2 instance, right? So EC2 instance is nothing but the virtual compute service of AWS. Like whenever you want to create an EC2 machine or a virtual machine, you will create an EC2 instance. Okay, you can think of EC2 instance as a virtual machine on cloud. Now, when you create an instance, right? So you have to specify what type of instance it is, right? So Windows, Mac, Linux, and all of that. And AMI is nothing but the Amazon machine image, which has all the operating system files, and it's basically the image, or you can think of it as an ISO, what we use when we install the operating system in our laptop or desktop, right? So that's one side of it. So don't get confused with AMI and instance. AMI are used to create an instance. Okay, that's the right way to think about it. Okay, so uh, okay, when to choose Amazon Lambda and Google App Engine? I'm not very sure about Google App Engine, but you are the best person. We are not, I'm not the best person to tell you which one to use. I can also always tell you about Amazon Lambda function or various other things. Now it's up to you to see what is the best that works for you, right? And as a student, I would always recommend you to see different services, not only from Amazon, and then take your own judgmental call, because there are different products from different companies, and all have its own pros and cons. But as long as it is serving your problem, or as long as it is serving your business, solving your business problem, you should go ahead with that. Okay, so what are the events that trigger the Lambda function? I hope you got some idea about that. There are different events that can trigger. One of the event that we have seen is S3 bucket, but it could be different events, right? I guess I had that in slide, but I did not cover it because it would have been too much, and I did not want to bore you with all different invocations. But I guess there is a slide where it shows all the events. Okay, no, there is. So I have mentioned few of the events, but it's not exhaustive, right? API gateway, timer, SQS, but there are many things that can trigger an AWS Lambda function, all right? So if you click on add trigger, you will see all those different triggers. It can be an IoT-based trigger from some sensors or camera. It can be from CloudFront. These are different services. Like DynamoDB, it can be a DynamoDB is a NoSQL database. So your Lambda function might get triggered whenever there is a new entry into that DynamoDB table, right? So it can be a Kinesis. Kinesis is a service for online data streaming. So whenever there is a new data in the data stream, it can trigger, and so on, right? So there are all different services which can be used to trigger your Lambda function. Okay. Then we have, what are the other questions? How do I troubleshoot serverless application? That's a very good question, Snehal. So there are different ways that you can troubleshoot. CloudWatch is one of the way that you can, troubleshoot, just like how we did that. I guess that was an old log, and we did not do, as you have seen, you might have seen, we have not done anything, but we have just deployed that. I guess that was not deployed. That's why, we were getting that error. But you should use CloudWatch, and there is another service called X-Ray. Okay, so this is a debugging and analysis tool or service for your application. So you can always use X-Ray for debugging. Okay, and there are different tools that are available for debugging as well. But you can always do that. So there is a. I would recommend you to now that you have mentioned that, you can make use of this SAM tool. AWS application, serverless application model. This is the tool that you would use to deploy your application, serverless application on AWS. So there are a lot of troubleshooting tricks there inside that as well. So although those are basics, but predominantly you will use CloudWatch and X-Rays. Okay, so there is one more question. If I'm using Amazon CloudFront, can I use Direct Connect to transfer objects from my own data center? Yeah, I think this is something different question, but yes, you can always do that. So if you're using CloudFront, so CloudFront is an CDN network for caching, and also you can hide your S3 bucket. You can host your website through using CloudFront. Can I use Direct Connect to transfer object from my own data center? I'm not very sure about that because I've not used Direct Connect as such. Maybe you can ping me later in LinkedIn. I can try to get the answer from the right team, because I do not use CloudFront as such and Direct Connect, so I'm not very sure about this. Okay, so all right, so that's about it. And one question that I have, and with that, I'll hand it over to the organizer. And feel free to reach out to me for anything around AWS or serverless or machine learning. If anything is not clear, if you want to get more clarity, 1 hour is little less, but I'll try my best to help you there. Okay. So here is the question that this is a very, if you have if you are awake during the session, you would have you would know this answer. Okay. So the question is. Which AWS service we can use, which can help to identify object, people, texts, scenes, or activities in an image or videos. Okay, so with that, I'll hand it over to the organizer. I think Kushan, you are on mute.
Sorry for that. So, sir, as I was saying, the session was really amazing and informative, and the demos were really illustrative. And I think everybody here has learned a lot today. Um, with this, I think we can end this session. On behalf of the entire ISTE VIT team, I'd like to thank you for taking time to out of your hectic schedule to bring us this session. And we hope that we can have more such sessions with you in the future as well. So thanks a lot, sir.
Sure. Thank you so much, everyone, for joining. Really pleasure to be with you. Thank you. Have a good evening.
So first of all, guys, I'd like to thank you all for tuning into this session. Secondly, one second. So yeah. So secondly, we are having a game night today at 10 p.m. and we are lined up a Valorant tournament finals. So make sure you guys look at it. We'll also be conducting Among Us and Scribble Chill sessions. So make sure you guys turn up and have some fun there as well. So as you guys know, the reviews at 8 p.m. have been going on. These reviews are for those teams who have not been reviewed in the morning session. So if you guys have not been reviewed yet, make sure that you check our Discord Technica announcements and then you join your respective table at the right time. And the second round of reviews that will be held tomorrow, and that's for all the teams, and that it will be on 10 a.m. So make sure you guys come up there at the right time. Keep an eye on our Discord Technica announcements. We'll keep updating it. And on this note, I would like to thank you guys for coming, and best of luck for your hackathons. And